In this video we're going to look at drawing parabolas. We're going to look at converting from our standard form to vertex form and using that to help us draw our parabola. Converting to vertex form is the form that looks like this, with two numbers that we need to determine. The first number is very easy to determine. It's just half our coefficient there, so we end up with plus 2 here, and I'll show you why that's the case. X plus 2 squared equals x plus 2 times x plus 2. When we expand that, x times x equals x squared, x times 2 equals 2x, 2 times x equals 2x, and 2 times 2 equals 4. We end up with x squared plus 4x plus 4. We are completing the square. We're trying to make this part a perfect square, and the only thing that works to give us our 4x from our original equation is 2. So x plus 2 squared is going to be the first part of our vertex form. If we look at our expansion of x plus 2 squared, we notice that it has a plus 4. We need it to be a plus 7. So therefore this tells us what number we need here. We need to add 3 to this to give us 7. So that means we have to have our vertex form y equals x plus 2 squared plus 3. This immediately tells us that our vertex is at the point minus 2, 3, the top one. Okay, now to help us draw this parabola, well, we could look for x-intercepts. But if our vertex is here and we have a positive parabola, we know it's going to curve like this, so there are going to be no x-intercepts. We can check this to find our x-intercepts, and this is true for any single graph, no matter what it is: parabola, hyperbola, cubic, straight line. To find our x-intercepts, you set y equal to 0. So that would mean we'd get 0 equals x plus 2 squared plus 3. Subtracting 3 from both sides, we get negative 3 equals x plus 2 squared. And when we try to take the square root, we're ending taking up a square root of a negative, which has no solutions in the real numbers. So therefore we know the reason for that is that it's not actually cutting through our x-axis. But we can work out our y-intercept. Our y-intercept, and again this is true for every single graph you draw, the y-intercept is where x equals 0. We set our x equal to 0, we know that we get just 2 squared, which is 4, plus 3 is 7. So 0, 1, 2, 3, 4, 5, 6, 7. That's going to be our y-intercept up there. So that's part of our parabola. What I would suggest now, to try and find the general shape of the parabola, is pick a line where we know that there are going to be two x values. In this case I am picking y equals 4, so I'm picking this line here. And I just go, okay, there's going to be two solutions to that, let's find out what they are. And the way I would try and attempt to find them is by setting y equal to 4 and trying to solve this, remembering that I should get two answers. Subtract 3 from both sides, I end up with 1 equals x plus 2 squared. Take the square root of 1, which means that I'll get plus or minus 1 equals x plus 2, because negative 1 squared will give me 1, positive 1 squared will give me 1. So that means I have two equations. X plus 2 equals 1, x plus 2 equals minus 1, so therefore I know the solutions are going to be x equals negative 1 and x equals negative 3. So that means at negative 1 I know it's going to be on that line, and at negative 3 I know it's going to be on that line. So sketching the parabola, I know it's going to come down through there, curve up, and go like that. Not a very good curve, because I can't draw very well, but you can get the general idea. If we were going to be doing this, we'd have to mark in our vertex. So our vertex, negative 2, 3. We'd have to mark in our y-intercept, which is at 0, 7. And we'd have to mark in our points here. So we've got negative 1, 4, and we have, oops, sorry, that's negative 3, 4, and that's negative 1, 4 over there. Okay, so that's converting to vertex form and using that to draw our graph. You can see that factorizing this equation wouldn't have done us much good, because we wouldn't have gotten it into a form where we're getting x-intercepts. So it wouldn't have been the right way to go in this case. So using vertex form has enabled us to graph this equation.